So, what would you do? What would be the first step for you to do the first problem? Very good. So we move the 15x over. We have to subtract. So we have 2x cubed minus 7x squared minus 15x is less than or equal to 0. From there, what should I do next?
Take out the x.
Take out the x. So we could factor out 1x, and I have 2x squared minus 7x minus 15 less than or equal to 0. Can I factor out that in the middle?
Yes.
So what's the first step to that?
To multiply the 2 into negative 15.
Very good, very good. Multiply these two, so I get a negative 30
And
and
get that to negative 7.
a negative 7. So what are my factors of 30 that would give me a 7?
3 and 10.
3 and 10, right? Now, who has to be the negative one?
Negative 10.
The 10, because that's the only way I end up with a negative 7. So then this becomes x, and then how do I do this?
2x squared
2x squared
plus 3x
plus 3x
minus 10x
minus 10x
minus 15.
minus 15. So this was factoring, right? And now we have to do the grouping part. So these two are together, just the way these two are together.
You take out an x on the first one.
So this x is still here. Out from here, I can still factor out an x. What do I have left over?
2x plus 3.
Plus 3.
And then you take away a negative 5.
From here, you should be able to factor out a negative 5. And then that is a 2x plus 3. Are these two parentheses the same?
Yes.
Great.
Okay.
So then this becomes
X
x
minus
parentheses 2x plus 3
Yes.
and
X
x minus 5. So how many things, and all this is still less than or equal to 0, less than or equal to 0, less than or equal to 0. So how many possible answers do I have here?
2.
3.
Oh, yeah.
Because the first one becomes x
X
equals
zero.
to 0, x plus, that's equal to 0, and that right there is equal to 0. So the first one's already what?
Solved.
Solved. This one becomes, we subtract 3,
X equals 3 over 2, negative 2.
so x equals negative 3 over 2,
And then x equals 5.
and x equals to 5. So these are my 3 possible answers. So what is the next step from here?
You make a line.
I need to make a number line. So I'm going to make the number line over here on the side. And who's my smallest number?
3 over 2.
Negative 3 over 2. And then 0. So I'm going to put the 0 here. And then the 5. So is this when you put your little brackets on the top?
Not yet.
Not yet?
I don't think so. Wait.
Just so you know what exactly you're talking about, right? So this one would be from parentheses, negative infinity to, now would it be a bracket or a parentheses?
Bracket.
A bracket, because it has the equal, correct?
Yes.
And then this one would be from negative 3 over 2 to 0. And then this one would be from 0 to 5. And then the last one would be from 5 to positive infinity. So those are your 4 possibilities. So I need to pick a test point for each one, correct? So from negative infinity to a negative 3 over 2, what would be the easiest point to use there?
Negative 2.
A negative 2. So I'm going to pick a negative 2 for that one. How about between negative 3/2 and 0?
Negative 1.
A negative 1. How about between 0 and 5? 2, that's fine, or 1. And what is 5 to infinity? A 6. So we're going to use a, I'm pretty still came out right. We're going to use a 6. So what is the next step? So we test them. So we plug in a negative 2 in here, or in this one, right? Now, please understand, you're going to have a calculator. Remember, this is a test. The last thing I want you is to fail. So, when you're plugging in the value, you could plug it in the calculator. Actually, this is what you could do, which is the easiest way. Your equation, this one, you could plug it into a graph. 2x to the third minus 7x squared minus 15x. Is that correct? Except I typed it completely wrong, right? Minus 7x squared minus 15x. Is that correct? I just want the equation. So when I do that, I'm going to go to the table. I care less what it looks like. At, what was my test point? At -2, what did I get? So the question is negative 14 less than or equal to 0? The answer is yes. Then what's my next test point? -1. -1 would have given me what? A 6. Is 6 less than or equal to 0? Nope. What's my next point? A 2. And a 2 is a? -42. It's right there. So a -42, is that less than or equal to 0? Yes? And then a 6. 6 is right there. What's a 6? 90. Is 90 less than or equal to 0? No. So the only one that worked was this one and that one. Do we agree?
Yep.
So my final answer would be -infinity, -3/2 union with a 0 to 5. Seriously? Is that what you guys got?
Yes.
Yes? Any questions on it? Which would be my parentheses. I mean, the stuff is there. Degree of 4, leading coefficient of 1. This 0 should become what? X minus 2. And this one should become x plus 10. And then that right there should become a crazy. Or it's what?
X minus 4
Mm-hmm.
plus 5i.
Mm-hmm. And
X minus 4 minus
so the parentheses is here for now, right? X minus 4 minus 5i. So originally it's something like that, but when you rewrite this is x minus 2, x plus 10. This should be x minus 4 plus 5i, and x minus 4.
Oh, that's that shift thing.
Yes, minus, that should be a minus 5i. When you move the parentheses. Are we okay?
I think that's...
There? Remember seeing this? Now the first one should be easy, the first two. What is x times x?
X squared.
X squared. X times a positive 10. -2 times x. And the -2 times
-20.
-20. So this here becomes x squared plus 8x minus 20. Do we agree with that one?
Yes.
Okay, so we're done with that part, but now we have to work on the other part. Now, what is the part that I should worry about first? The x minus 4 and the
X minus 4.
x minus 4, right? So what is x times x? X squared. This is together, and then we're working on this one. X times the -4. -4 times x. And -4 times the -4 is a? Alright, and what do we do with these two guys? So that becomes a -25i squared. So we only take care of these two. At the very end, you multiply the last two. Now, what can we combine here?
4 and 4.
So we have x squared minus 8x plus 16.
Plus? Oh, just kidding, yeah.
Now, that negative 25 becomes negative 25 times what? Negative 1, which becomes a?
Plus 25.
All right, can we combine that right now?
Yes.
What do we combine? And 16 and 25 becomes? 41. Now, what do you do with those two? Do the distributive, right? Yes?
Yes.
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 So we have x squared times x squared,
X 4.
x to the fourth. X squared times a negative 8x,
Negative 8x to the third.
x squared times a 41.
41x squared.
Now, to keep your stuff in order, this is the way I would go down about it, but you could write them across whichever way you want. So I did the first one times those three, right?
Mhm.
Now it's time to do the 8x times those three. So what is 8x times x squared?
8x squared.
So I am going to put it right underneath the cube because it's cubed.
That's what I do.
What is 8x times a negative 8x?
Negative 64x squared.
Negative 64x squared. And then what is 8x times 41?
Let's see. 8 is 28.
8 times 41.
298.
328.
Oh, just kidding. Haha.
So positive or negative? Positive 328x. So you have a calculator, make sure you use it the day of the test. And then the last one would be the negative 20 times all those. What's a negative 20 times x squared?
Negative 20x squared.
Negative 20x squared. Negative 20 times a negative 8 becomes a positive
60.
160x. And then what is 20 times 41?
Negative
820.
820 is correct. So then we kind of work with it. The x to the fourth is to combine with anything. No? That's it. What happens with these two?
There's a crop there. I cancel.
They cancel. So what is 41 minus 64 minus 20? Now, remember, you have a calculator, so use it. So I have, okay, 41 minus 64 minus 20. Here. So, we already heard that, is it negative 43?
Yes.
Yes? So it's a negative 43 x squared. And then what is 328 plus 160?
48.
488 x. And then minus 820. And there, you are done. That's your answer. So is my leading coefficient 1?
Yes.
Do I have to multiply times anything?
No.
Because remember, if your leading coefficient happens to be something else, then that's when you have to multiply the whole thing times 2 or whatever. It's my degree of 4? Yes. There it is.
So, if it said the leading coefficient is 2, then at the end you multiply everything by 2,
Mm-hmm.
and that's what would be your final answer.
Mm-hmm. So for problem number 3, they give it to you like that. We have to use the leading coefficient test to determine the graphs and behavior. So this is where you know if it's in even or odd. So by looking at this, is this an even or odd function? This is 3, but this one has a what?
1.
A 1. And what is 1 plus 3? 4. So 4 is my degree, which means it's going to be what?
Even.
Even. And is it negative or positive?
Positive.
What is the number in front,
I mean,
guys?
that's a negative, yeah.
It's a negative. So my leading number it's a negative even. Now, because it's a negative even, do you remember what it was? Does it fall on the very end? Does it rise? What does it do?
Which chapter? I mean, which lesson?
Which lesson? That's a very good question. It is lesson 3.2. So according to note to 3.2, if it is even and it is negative, and here are all the scribbles, the graph falls to the left and it falls to the what?
Right.
Right. So that's what you would put here. False left, false right. It would be the same thing on your test. Are we good?
Yes.
Same thing.
Same thing. Different numbers, but same thing. So, how do you find the x-intercepts? Is this thing already completely factored?
No. Yes.
Yes, it is. It is completely factored. Now, when we're looking for the x-intercepts, all you have to do is set each of those equal to 0. So I have -2 equals to 0. I have x minus 2 is equal to 0. And I have x plus 3 is equal to 0. Now, the x plus 3 is really there how many times? 3 times because of the power of 3. But do I have to do it 3 times? No. Now, does this become anything? Nope. This becomes x equals 2. This becomes x equals -3. So when I'm looking for my x-intercept, I would love to see the point 2, 0, -3, 0. Those are my x-intercepts. Are we good? Easy? So you got 4 points for this, 4 points for that. Now, the next one, find the multiplicity of the zeros and state whether the graph crosses or touches the x-axis and turns around at each 0. So, how many things, do you remember how you determine the multiplicity? No? Yes? Anybody?
Yeah.
You put in the calculator, but it's also by looking at the equation. What is the exponent of the 2? 1, so it's a multiplicity of 1. The -3 comes from here. It's a multiplicity of what? 3. So I'm going to put here so far 2 multiplicity of 1 and -3 multiplicity of 3. Now the question is, does it cross or does it touch and turn around? And for that part, like I heard over there, you do have to graph it. So let's go ahead and get our graphing calculator, and you input the top equation, which I'm going to do right now. -2 parentheses x minus 2 x plus 3 raised to the power of 3. Does that look correct? So I graph it. Are they crossing or touching? Both of them what? If the line goes through it, it what? It crosses. Does the 2 go through it? Yes. How about at -3? Yes. So we're going to put crosses. Crosses. So there, I'm done with that part. So does everybody understand what the multiplicity came from again? Yes? Why we know if it crosses or if it stays or if it just touches? Yes?
You just put in the equation, right?
You put in the equation and you graph it, and that was it. And you look, if it crosses, well, it crosses. If it touches it and it goes back up, then it's the other way, or it's the other one, the one that touches and turns around.
So it's always going to do either one or the other?
Mm-hmm. Find the y-intercept, write your answer as an ordered pair. So, for this one, how do you find a y-intercept? Who has to be 0?
Why?
At the y-intercept, who's 0? X is equal to 0. So I'm going to take the top equation. Y equals -2 parentheses. Instead of putting an x, what am I going to put?
0.
A 0 minus 2 close parentheses. What am I going to put here?
0.
0 plus 3 cubed. So I'm going to do -2. 0 minus 2 becomes what?
0. I mean -2.
And what is 0 plus 3?
3.
But that 3 is cubed.
So 27.
So -2 times -2 is 4. Do we agree?
Yes.
And then this is a 27. And this together is? It's 27 times 4.
108.
108. But is that my answer?
No.
They want the answer as an ordered pair, so what is it?
0, 108.
0, 108. Also know, how do you verify? Because remember, here it's not just, I need to find the answer, but I need to check that I've got this correct. If I already entered the equation here, can I go to the table and can I see at 0? Oh my God, it's 108. Yes, I got those 4 freaking points. I got this. I want you to be excited. I want you to check. Graph the function.
It's Control T, right? Or Control T.
Control T. So to graph the function, the only thing, good information that I have is, I know it crosses at -3. I know it crosses at a 2. If I look at this, can I graph any of these points, honestly? That's a huge number. I could probably graph which one also? -2, 8. And this is where you just need to use what you can, not that. That one's too big. So when we ask you to graph this, please understand, all I could do is something like that. I don't know what happens up there. This thing seems to be going like that. That's the most I could do. But please understand, the dots that you could graph there, you better put them there. I just don't want for you to do like, I want to see the dots that do fit on the graph, you have to put them. And those are easy 4 points.
Wait. So we're graphing which function?
The original one.
The one all the way.
Yeah.
So we can also put it in the calculator.
That's where I got the points from the calculator. But what I'm trying to say is, there is a point there, you better put a point. I don't want for you to look at your graph and go, it does some crap like that, with no dots on there. I better see those dots that happen right there. Are we good?
Yes.
So when you look at this problem, we're talking about zeros, and that rational zeros theorem, it says list all the possible zeros. Now, the way this was taught was I have to get the last number, which is my constant, right?
Yes.
And my constant is 2. So what are my only ways that I could get a 2? Plus minus 1, plus minus 2. And then you were supposed to get your LCE. Do we agree? And that is my leading coefficient, and that is a 9. So how do I get a 9? Plus minus 1?
Minus 1, plus minus 3, plus
And?
minus 9.
9. Those are my only possible ways. Now, at the very beginning, he would do this table where it was a 2, 1 and 2, a 9, 1, 9, 3, 3. If that helps you come up with the numbers, do it. Now, how do you come up with the possible zeros? It's who divided by who? Was it the constant divided by the LCE? Yes, and that's why they're in that form. So I have 1 divided by 1 is 1. 1 divided by 3 is 1/3. 1 divided by 9 is 1/9.
How do you get those numbers again?
My multiples of 9 are 1 and 9, 3 and 3.
Oh, because that's your...
My multiples of 2
yeah.
are 1 and 2. So my other list of numbers is going to be 2 divided by 1, which is 2. 2 divided by 3, which is 2/3, and 2 divided by 9, which is... Now, do any of those repeat? Can any of those be reduced?
No.
No. So, am I done?
No.
That's 5 points. You are done. That's it. Yay! Now, use synthetic division to find the first zero. So, here's the shortcut to this. Synthetic division comes from using the original equation, right?
Yes.
So, which is the numbers I'm supposed to use? 9, -15, 8, and -2. Now, how do I know which one my first zero is going to be? You were supposed to play around with it and figure it out, right? You try one, doesn't work, try the next one. Well, here's a shortcut because I want you to do good on the test. I'm going to graph the first function. So, grab your calculator and type that into its place right now.
I don't have one, miss, because I never used one in this class. I'm just a genius like that.
Alright, so this is the equation. 9x cubed minus 15x, and I forgot the x after the 8. This is why you double check, and I press enter, and this is my graph. There's only one 0, there's only one x-intercept, and what is that one?
-2. Oh, just kidding, 1.
It's 1. So where does this graph cross the x-axis? It is an x-intercept. The x-intercept is also called a 0. So guess what number we're going to use here? And it will work. Which one? 1. Because it crosses your graph where? At 1. So please understand, since this is 1, I will use a 1 right there. So we go ahead and do this. How do you do synthetic? Remind me, please. First one down. That's a 9. Multiply. That's a 9. -6. So it's a -6. And then this is a 2. And then that is a 2. And this is a 0. That's what they want. They want that to be a 0. If it's not a 0, then it's not a 0. So guess what? I already did what I had to do there. This equation is, just kidding, remainder constant x squared. My new equation is 9x squared minus 6x plus 2. Why do I need to know this? Because what does the next step say?
Remaining 0 by factoring to find it.
Or using the quadratic formula. Well, let me tell you something. You're going to have to use the quadratic formula. Now, in order to use the quadratic formula, you need to know your A, your B, and your C. And there it is. Everything gets in my way, I tell you. Alright, so my A is 9, my B is, and my C is 2. So x equals -b plus or minus square root b squared minus 4ac all over 2a. So we plug in the numbers where they belong. -6, -6, 9, 2, and 9. Now I need you to know, just the way on this review, your answers will be imaginary here. On your test, they will be imaginary also. Okay?
Wait, what do you mean by that?
We'll find out.
Okay.
They're all going to be negative.
What's a negative times a negative?
Positive.
So that becomes a positive 6 plus or minus. What's a -6 times a -6? A positive 36. But then I have -4 times 2. -8 times 9.
-72.
-72 all over 18. Now, what is 36 times a -72?
-36.
Oh, -36. What the heck? So, what do we know about having a negative inside of
6i?
it? Becomes imaginary. So that's what I'm trying to say.
Okay.
You're going to end up with a negative in there on your test also. So your answer is going to have an I. So I don't want for you to think, oh my God, I did something wrong. So I have 6 plus or minus 6i over 18. Do we agree?
Yes.
But this breaks down into
3
6 plus 6
plus or minus.
so 6 over 18 plus or minus 6i over 18. Can those be reduced?
Yes.
6 goes into 6 one time. And 6 goes into 18 how many times? 3. And this is the same thing. So you could keep your answer like this, or you could keep your answer at 1 plus 1i over 3. Whichever way I'm okay with. You either keep it as 2 separate or not. Why do I separate them? Because sometimes we forget to reduce both sides. So we agree.
What happened to the 72?
What's 36 minus 72?
It's 36? Oh shoot.
That's where that came from.
I thought you just took it out.
No. You can't do that in math, unfortunately.
Is there supposed to be a minus on the second one?
Yes, my bad. Plus or minus, thank you. Plus or minus 1i over 3. Are we good with this one?
Yes.
Yes?
Ma'am.
So here's the last problem. In order to be able to do this, we have to factor out both the top and bottom. So what two numbers multiply to a negative 30 but adds up to 1? 6 and 5. Who has to be positive?
6.
The 6. Very good. That's awesome. You didn't have to do a table. What two numbers multiply to a negative 20 but adds up to a negative 1? Multiply adds up. 5 and 4. Who's positive?
5.
The 5 is negative. Very good. Because I need a negative 1. So those are your factors. Do we agree?
Yes.
So this is 3.5. This is where this is coming from. So the first thing we have to do is find the symmetry of f of x. Now, remember, it could have been over the origin or over the x, or over the y-axis, or it's neither. So in order to know if it is over the y-axis, we were supposed to substitute every x with a negative x, and if it stayed the same, then it was over the origin. Do you remember? Yeah?
Somewhat.
So a negative squared becomes a positive. Plus and the negative becomes a? It's a negative, sweetie. So this stays a positive, or it becomes a positive. This now becomes a what? A positive. So the question is f of x equal to f of negative x? Are they the same? No. So then, is there symmetry about the y-axis? No. How do we find out if there was symmetry over the origin? Do you remember?
Negative.
We would put a negative in front. Very good. So if I put a negative in front of the whole thing, x squared plus x minus 30 over x squared minus 20 over. This becomes a negative x squared minus this plus 30, negative x squared plus x plus 20. So everything changes. That should be equal to the original, to the negative. Which one was it?
Negative.
To this one?
Yes.
Are they the same?
Yes.
Really?
No.
What am I looking at differently?
This one
Oh, just kidding.
and
never
this
mind.
one?
Uh-huh.
Are they the same?
No.
No. So guess what you're finding the symmetry, if any? Is there any?
No.
So we're going to put none. The same thing will happen on your test, but you need to make sure you show me. Are we good? Okay. So can we move on? How do you find a y-intercept again? Remind me.
Set your x equal to 0.
Set the x equal to 0. So I'm coming over here. Y equals 0 squared plus 0 minus 30 over 0 squared minus 0 minus 20. So I replace every 0, and it goes back to this equation. I know I have a lot of writing here, but it goes back to this one. I substituted every x with a 0. 0 squared is 0 plus 0 minus 30. The top is just what? Negative 30, 0, 0, and a minus 20. Does that reduce? And what does it reduce to? 3 over 2. But I need to write my answer as an ordered pair. So what is my answer? It's negative divided by negative, so it becomes a positive. So you could either put 1.5 or 3 over 2. And there, I'm done. Am I okay with that one? Yes? Now, how do you find your x-intercepts? It is only the what?
It is only the...
I really think we should answer D first, before that one. Now, D says to find the vertical isotopes and or the location of the zeros, if any. Now, how do you find the vertical isotope?
by, was this 3.5?
Yes. What do I have to look at here? How do I know if there's a hole? Do you remember what made the holes? Having the same what? On top and bottom. Do I have the same equation on top and bottom?
No.
Yeah.
Yeah.
Renee, look at this, my sweetie pies. Do I have the same thing
Oh,
on
yes,
top and
on
bottom?
this.
Yes. So do I have a hole?
Yes.
Yes.
¿Dónde estás? My hole is going to be x minus 5 is equal to 0. My vertical isotopes comes from all this comes from the denominator. You need to know that. It comes from the denominator. So if my hole is x minus 5, what does that make my x plus 4?
The domain. Oh, just kidding.
My
Denominator.
vertical isotope, sweetie pies.
Oh.
And it is my denominator. We have to set it equal to 0, and there it is. So my hole is at x equals to 5. My vertical isotope is going to be at x equals negative 4.
Wait, where do you get that x plus 4 again?
It only deals with your denominator. Vertical isotopes and denominator deals from your denominator. Okay, are we good?
You go back to the
Of course I can. There it is. Now, do you remember how to find the horizontal isotopes? There was 3 rules.
And let's do the,
Which one is?
less than the denominator. Oh.
So let's look at my degrees. My degree on top is a what? My degree on the bottom is a? So they're the same. So when it was the same, what was the rule? Y equals LC over LC. Do you remember that one?
Yes.
What did LC stand for? The leading coefficient. So what is my leading coefficient on the top?
2.
And what? My leading coefficient?
1.
1. And what is my leading coefficient on the bottom? Of 1. So what is 1 divided by 1? So my answer here is going to be a 1. Does that make sense? So are we okay up to right now? Yes? Now, the only thing that I'm missing is my x-intercepts. And we need to understand one little thing. When I look at this, my intercepts come from my numerator. But am I able to use both of these as from the numerator? The negative 5s are gone because they are a what?
Denominator.
A whole. So the only thing I have left over here is x plus 6 is equal to 0. That makes my x-intercept be a
Negative 6.
-6. My point is a -6 comma 0.
So on the test, if it's in that order, should we do D first?
It's going to be in this order. I just think it's just easier if you do that one because you know who you're going to eliminate. Now, please know, what do you have the day of your test? Calculator. So when I graph this, this is what it's supposed to look like. Except it's turned off. So if you look at this, is there an x-intercept at -6? Yes, there is. I'm still supposed to graph this. Now, remember, please, that there is an asymptote, vertical one, at where? X equals -4. So when you graph this, I want to see a dotted line through there. You're telling me there is that fence, there is that line that I cannot cross. Where's your other asymptote at y equals what?
5.
Y equals 1. So at y equals 1, you're supposed to have another little dotted line. Right, like that. Now, when I sketch the graph, I could look at it, I could get points from here, and I already know my graph is going to go through -6. But you still have a calculator. You do Control T, and you find other points, please. Oh, look, pretty ones. I don't see anything in the negative sides. I
Yeah,
could,
problem.
-5, -1, that's perfect. -5, -1. Can I do anything close to the 4? No. Those get kind of crazy. 2 dots is enough for me to say, this is what's going to happen, it's going to curve and it's going to get close, but I'm not touching, I'm not crossing that dashed line because I'm not supposed to. It sets the limit. That's what an asymptote does. It sets the limit. So then I have to go on the other side of the -6, of the -4, and can I sketch -3, 3? -3, +3. There I am. -2, 2, -2, 2. And it's supposed to be, but remember, what happens at the 5? There's a what?
Undefined.
Undefined, because there is a
X.
hole.
Hole.
At 5, I want you to just put a little open circle. Try not to color it in. I colored it in. Bad. Open circle.
It's a. It's above 1.
It's above 1, yes. Open circle. Make sure it's an open circle. There's a hole. Hay un agujero. That's why it has to be open. And boom, you're done with your test. Now, everything on the test, have we covered it?
Yes.
Yes.